Okay, so let's get started. It's we are going to talk about feedback loops in Agile software development, and I think it's very cold here. It's really cold, and I think you agree. It's really cold. And I suggest that we will we'll solve this problem by building a fireplace right here. Let's assume that this thing there's no fireplace, so we'll build one. We will build one. Okay. So what do you think about this idea?
It's quite warm, actually.
Is it? Yeah? It's quite warm for you? Oh, okay. Yeah. I think it's cold, really. But it's warm for you. Okay. Anybody else thinks it's quite warm?
It's hot.
It's hot. It's hot. Well, and if let's assume for a second if it were cold, how about my idea about building fireplace? What do you think about this one? Because I mean, it's something. If it were cold, right, it would be unpleasant to sit here, right, for an hour in the cold. So I suggested building fireplace. What do you think about this idea?
Take too long.
What?
I think it would take too long.
Take too long. Okay.
If you want something simply why fireplace, why not something else? Maybe we could look at other solutions.
Okay.
If it's just for an hour, it definitely would get benefits in the time you leave.
So what did I just do? Okay. So let's look at this, right? So I made an assumption, right, based on my personal perception, right, which is apparently wrong, right? But we don't always know about the fact that our perception is wrong and it's different from the perception of marketplace, right? And I thinking that it's a great idea, right? It's the right assumption. I propose solution. I propose to build a fireplace, right? It's a crazy idea here, right? And then I asked for feedback, right? So instead of going and thinking, my idea cannot be wrong, I'll go build a fireplace, building it, and be done with this, right? And spending time and money for something which is absolutely inappropriate, right? I went and asked for feedback. So we are going to talk about feedback, right? Feedback is essentially when I want to check, right? If I want to check reality, right? I make some assumption, right? I had some hypothesis, right? And I want feedback, right? I want to know what other people think about it, right? I want to check the reality. So I'll give you some examples of feedback which have nothing to do with software development, right? With things which happen in life. Like driving the car, it's a constant system of the feedback, right? Because you drive the car, you see that you go to the left, so you steer it to the right, you go a bit to the right, you steer it to the left. You go too fast, you hit the brake, right? You go too slow, you hit the gas, right? So it's constant system of feedback, right? You perceive the conditions around you, they give you feedback, and you adjust, right? A little bit more interesting example is painting the house. So I don't know if anybody has ever done it. I have not done it myself, but I've observed people doing it. So that's usually the process that you kind of go through, right? What's interesting is that at every stage of this process, you're kind of trying to get feedback, right? So, and who is a customer? In this case, it's actually your eyes, right? So, what you look at the house, you try to imagine how this color would look, right? And you're asking your eyes or your brain, is it going to be nice? Is it what they want, right? And you're discussing, you're getting some feedback, right? Then you're looking at samples again. Your eyes give you some feedback, right? And so on and so forth until you painted the whole house. Now, what happens here, right? Well, first of all, we notice that as in each of these feedback loops, right? As we go along, it gets more expensive, right? This is very cheap, right? This is already kind of a bit more expensive. This is really expensive, right? You spend time, money. Now, if you don't like it at all at this stage, you have to redo the whole thing, which is complete waste, right? So as we go along, it's more expensive, right? Also, as we go along with the feedback loops, right, we get more confident that what we are doing is right. So when I'm just imagining the color, yeah, maybe, I don't know, I can't tell. I need to see it, right? But when I'm at this stage, right, I'm pretty sure that once I get here, it will be okay, right? Not 100%, but very close. So the risk here goes down as we progress, right? And confidence increases. Okay? So that's essentially what I just said, that we need to try, right? We learn by doing. Okay? And the big question is what feedback loops are for, and here we're coming to software development already environment, and we're trying to see what would we use feedback loops when we build software. And actually, it's because feedback is such a universal thing that there will be a lot of analogy between how we employ feedbacks in our everyday life and how we employ feedback in software development, right? So the two main questions that we are trying to answer when we build software is whether we are building it right and whether we are building the right product. This question has to do mostly with technical stuff with building software. This question has to do mostly with the business size of building software, right? So what do we gain from feedback loops? They allow us to reduce risk, right? We've seen that painting the house, right? It allows us to reduce risk, right? The further we go, the less risk we have, right? It improves the quality, right? Because one thing is that I don't have any feedback loop, but I just throw something on the market, and maybe it's just really poor quality and nobody wants it. It's this way, right? Whereas if I had intermediate feedback loops, I would have known. And consequently, it improves customer satisfaction. I don't have a slide for this, but I will draw an example. So let's say you have to sail, right? I hope nobody sails here because I know that I don't sail, right? But I have this example, and if anybody sails here, it's going to tell me that it's all wrong, but let's assume that it's a fairy tale that everybody accepts, right? So we are going to sail, right, from Dover to New York City. Okay? And I give you several options, right? The first option is you don't have any maps, you don't have any navigation equipment, nothing, right? You just have to sail, right? Essentially. And whether you got there or not, I'll tell you once you tell me that you are done, you see the land, right? You arrive on the shore, I'll tell you whether it's New York City or whether it's somewhere else. Okay? That's one option. Another option, I'll tell you, okay, I'll be easy on you. And so this is one option, right? The second option, midway your trip, I'll tell you where you are. I'll give you the location so that you can adjust. Okay? Essentially, I will give you feedback on how you're doing. Okay? The next option would be along with sailing, I will be giving you feedback once a day about the location where you are. Okay? Then next is I will be giving you feedback every 3 hours. essentially telling you what location, which is your location, and here you will have constant feedback. You will always know where you're located. Okay. So what's probability of getting to New York City here? 0, right? Okay. Here it's a bit higher, but it's also 0, right? So here what will happen is you will go off course north or south, right? Until the middle of the trip, and then you have to make a correction, a lot of rework, and then continue. Here you have a better chance. Actually, I think you will be somewhere close, not New York City, but somewhere on the east coast of the US. And you will have to make corrections several times during the trip, right? But again, every time, so you will be deviating, and then you will need to come back. You will be deviating again, you need to come back. So it's constantly working, constant corrections. Okay? Here, the corrections will be smaller, much more often, right? And more it's very likely that you will arrive where you're supposed to be, and here there will be almost none, right? So you constantly know where you are. No corrections, right? So these are all feedback loops, right? What's the difference between them? The difference between them is that this feedback loop is a very slow, get feedback only here. This feedback loop is also very slow, right? Very long feedback loop, very slow. Huge risk, right? So as we go this way, risk decreases, right? As we go this way, the feedback loop gets shorter and shorter and shorter. Okay? Our confidence goes up. It's smaller feedback loops. It's shorter feedback loops. Okay? So, let's try to see where this is applicable in software development. This is traditional. This is a picture of traditional software development, right? So, if this is Dover and this is New York City, traditional software development, what it does, we have an idea, right? We write specifications, we do a lot of development, almost no feedback, right? We do testing, that's where the first feedback starts coming back, right? But we do testing somewhere here very late, right? And then we go and try to deploy our code. Again, if we didn't do really good work on ensuring the deployment will go smoothly, most likely deployment will fail, right? So we know that very often we deploy something which works in our testing environment, and in production environment it will fail, right? It will not deploy correctly. There will be firewall problems, maybe there will be database problems, whatever. Whatever you can imagine, it will happen, right? And then you essentially deploy it, it gets into the market, and then you get the real feedback, right? It's constantly cash, right? So you invested $5 million, and you were hoping to get $10 million back. But if you got back only $100,000, then it's not a very good project, right? So the problem here is that we don't have any confidence as we go along, right? We don't know where we are. We don't know when we will be done. We don't know anything about the quality of our software until we start testing here. Also, even when we start testing, it's not that obvious about the quality in the traditional way, right? We don't know how much rework we might have. If we didn't work here good enough on verifying our idea, then the whole thing can be just worthless, because when we deploy it to the market would have changed, even if it was a good idea. But if it wasn't a good idea, even at that time, even to start with, then just nobody will want this to use this software, right? To use this product. So that if you didn't check anything here, most likely over there will be a problem. So how do we build in this confidence and this feedback into software development? Can we do any better? Yes, we can. And that's how we do it. Okay? So essentially we build in feedback loops. Okay? I will say a couple of words about them and then we'll go into details about each one of them. So what's exploration? Exploration is when I have an idea, right? And before I start building anything, I want to somehow figure out if is it worth anything, this idea, right? Is it going to fly? I don't know how. There are multiple ways, right? Marketing research, focus groups, a lot of things, right? Possible here. But that's very important to get feedback. And only if this feedback, after we look at this feedback and think it's worth it, then go ahead, right? Then, because if we don't do it, right, what's the other option? Seems like it's a good idea, right, to build a fireplace. Let's do it. Let's spend money, time, let's put it on the market, and then we have this real, by the way, this is the only real feedback loop. These are all artificial feedback loops. This is the only real feedback loop. Concept of cache, right? And so we can just put it on the market without dealing with this, and we'll see it, right? The market will tell us, but it's hugely expensive. Nobody will do it like this. Well, nobody would want to do it like this. So in the process of development, there are feedback loops when we write code, right? When we write unit tests, when we write integration tests, when we integrate our system with other systems, right? When we have this feature or user story, whatever you call it, complete and we get feedback from product owner or the customers at the acceptance phase, right? During the sprint review, during the demo, right? And then the next one is what we want to deploy, right? So there are two ways to deploy it, right? One way, well, everything in the middle. One way to deploy it, it works on my PC, so why wouldn't it work in production? It's the wrong way to deploy it. And the other way to deploy it is I have production environment, and I have another environment which replicates production 100%. It's exactly the same as production. It works in this environment. I have very high confidence that it will work in production environment. That's this product readiness loop, right? And monitoring is that this post-release, after we release, we want to monitor the software, we want to monitor the product, its health, and see what's going on, right? So to get feedback, right? Because if I have a website, right, which is supposed to accept payments by credit card for, I don't know, for buying books or whatever, right? And suddenly something went wrong, and there's no payments going through. If I don't have any monitoring, if I don't have any feedback from the website, right, about how it's doing, and I don't have a customer service which will be overwhelmed with the calls, right, I probably wouldn't know for quite a long time, maybe several hours, that something happened, which is really bad. It lose a lot of money. Okay, and then, so essentially, overarching loop, feedback loop, which is constantly cache. Okay, so now let's go into and look at feedback loop characteristics, because they all have characteristics. So there's a speed, right? We already talked about the speed, right? How fast is the feedback, right? Here feedback was very slow, right? Here it goes real fast, like immediate feedback, right? So when I write a unit test, right, it's very quick feedback, right? So I wrote it, click it, works, it doesn't, okay? when I have a user story, this is technical feedback, right? So when I have a user story, right, that at the end of the sprint, let's say it's 2 week sprint, I show the product owner and ask him, is it how you wanted it? And he tells me yes or no. It's pretty long time, right? So it's not a very fast feedback, it's pretty slow feedback, right? Now, but the cost, right? So unit test is fast, it's very cheap, right? This is hugely expensive, right? Okay. This overarching feedback loop is hugely expensive. Also, if I work on the story, if the whole team worked on the story, we show it to the product owner at the end of the sprint, the product owner looks at this first time, right? First time, right? So he wasn't playing it, and then the first time he looks at this in 10 days at the sprint review, looks at it and says, okay, it's a great job, it's just not what I want. Why? Because he never looked at it during while we were working this, right? And there was probably no good conversation about acceptance criteria, what's expected from this story, right? Because it's expensive, right? We spend all this time and money. There is a risk. Risk is not really characteristic of the feedback loop, but risk is kind of characteristic of the where we are, right? So if we are at the very at the very beginning, like this small feedback loops like with unit tests, right? Or when we write software, another type of feedback loop when we do pair programming, right? It doesn't build much confidence, right? It tells us we are doing the right job. We're doing it well, right? We are writing the software the way we are supposed to write. But whether this will fly in the market, whether it will generate money, we have no idea, right? The risk is very high, right? Whereas when I have the software already in the marketplace for a certain segment of the market, right? And we see that it works, the confidence is much higher, right? The risk is much lower. Source, it's either human, which is product owner or customer, right? Or the marketplace, or it's technical, automated, essentially source, right? The unit test. Scope, it's either small or it's large scope, small scope, like unit test, right, or integration test. Large scope is, for example, when we monitor the whole system, right, after the release, right? It's really large scope. Why is it large scope, right? Because if we see that orders are coming in, right, at the rate that they're supposed to come in, then we know that whole software is working, right? That we know that everything else which was before is working. It means that the test, we coded it right, the tests are done, the integration is done, right? We deploy it correctly, so it's really proves that the thing is working. And confidence, which is similar to risk, right? Less risk, more confidence. And then either artificial or real, and so as I said, all these loops are artificial loops, and this is the only real loop. Okay? So I'll go quickly through this because I already talked about some of these examples. So for example, really fast feedback is, so anybody ever programmed in VI? Okay, VI is a very ancient editor, right?
Oh.
People still VI, right? So people still use it, right? So it's, for those who have never seen it, it's like Notepad, same thing, right? So you don't get any feedback, essentially just black text on white background or vice versa, no feedback, right? So you can write the code there perfectly and then put it through the compiler, compile it, and the compiler will tell you that instead of for each, you wrote for each, right? So it doesn't check it. So there's no feedback. As opposed to this, when we use good IDE, right, like Eclipse, right, it gives you constant immediate feedback. So if your syntax is not correct, you constantly get feedback from IDE, even before you start to compile, right? it gives you the feedback right away, right? So that's an interesting thing. Example of fast feedback in pair programming. When you do pair programming, it's very fast feedback because when you essentially exchange ideas all the time, right? So I write something, I say, well, I'm going to do it like this. Well, yeah, but what if we try something else? Okay, let's try this. Works? Yeah, okay, it seems like it works. So it's very, very fast feedback. Another example would be continuous integration server. I don't know how many people know what it is. It's the thing that builds the whole code base, right? And it runs all the tests. So if I check in my changes, it picks it up, builds the whole thing, and tells me if everything is good. So it's green or red, right? Red, it failed, something's wrong. I don't know what's wrong. Of course, we know when we do it, it doesn't matter what's wrong. It's red, right? It needs to be fixed. Or green, everything is fine. So ideally, on the check-in, it should take like 5 minutes for the feedback to come back from CI server. It's very fast. So this example there. Another property is cost. So this is very cheap, as we said. This is pretty expensive for using MVP to the market, right? And figuring out that it's not working there. It's expensive. Risk, we talked about risk. So there are different ways of looking at risk, right? The way I just want to make sure that everybody understands why, for example, unit testing pair programming is high risk, right? It's not that unit testing pair programming is high risk, but when we are at that stage, right? When we are at that stage, we are both good developers. We are writing the code. We are doing well, but we don't know if it's going to fly in the marketplace, right? We know that it's probably about 3, but that's about it. Source, the Matukhin, that's pretty clear. Scope as well. Confidence, we talked about this as well. And now let's talk about the feedback loops, right? We talked about this a little bit. This exploration feedback loop, right, which happens at the very beginning, right? Risk is still very high, right? Because we're at the very beginning, right? We have low confidence, right? But we really have to do it. Otherwise, I mean, developers will build whatever you tell them to do it. Right? If it doesn't have any business value, the concept is wrong. It's not worth it. It's just not worth it. So that's this huge improvement, right? But because we cannot predict everything in advance, right? We want to learn from the marketplace. What's even more important is to build in very small increments. To have our MVP, minimum viable product, as small as possible. Then we would release to the market as soon as we can, and we'll start getting information back from the market. So instead of spending 6 months, right, on building an MVP, right, we can build the MVP in 1 month and release it quickly and start getting information, start learning from the market, start making adjustments, right? It's much cheaper, much better way, right? We will ultimately generate much more money. Coding, that's the next thing. Not much to say about this. Just good coding standards should be applied, right? Preferably so that you get good feedback from the coding practices. This is getting more interesting. Unit testing, especially when you apply TDD, test-driven development, because test-driven development really connects you to it's kind of more, you know, it's more, it's the feedback that you are really asking for, right? So you are setting up, okay, what this piece of code is supposed to do, and then you're implementing this, right? And then, okay, is it doing this actually? Is it green, red? Green, positive feedback, red, negative feedback. You can change it. Okay. Integration testing, usually performed on CI server, right? and it can be very fast. So usually you would split it into several test suites, right? The first one is running very fast. As you check in 5 minutes you get feedback, right? Another one we might run every 2 or 3 hours during the day, right? It's longer running tests, right? But you will have your feedback every 2 or 3 hours. Another one maybe runs every 6 hours or 12 hours, right? Even longer running tests might be performance tests, right? So your confidence goes up here, but so far it's only from the technology side. You still don't know anything about it. You know that you are building the product right, more and more, but you don't know if it's the right product. Okay? Here's where we start talking about the right products. So when we show to the product owner what we've done, the product owner looks at this and says, yeah, this is what I want. Or we show it to the customer during the sprint review, and he looks at this and says, this is exactly what I want. And when we show it, and we show a live working thing, it's not only that in terms of technology we did it right because it works, right? Well, maybe in the test environment, but it works in this environment, right? But we also know that what we build is what customer wants. So it's much more confidence that when we release this product increment, it will generate some money. Demo, right? And you know what? There's one thing I want to talk about here, which became really popular the last couple of years. It's acceptance test-driven development and behavior-driven development specification. By example, I don't know if you do it, but this is really a good thing because it builds a feedback loop which is executable feedback loop, right? So you build in the requirements, right? You get requirements, so you have this communication with the product owner, you build requirements, and you test these requirements, these executable requirements, right? So once you execute them, right? So you know that what's working is exactly what product owner wanted. I unfortunately don't have time to go more into this, but if you have questions about it, you can come over to me and we can talk about this. This is really powerful stuff. Acceptance test development. It's when acceptance test. So traditional acceptance test would be what? You write it on the back of the card in Scrum, right? And in the demo, product owner reads this says that show me that this works, show me that works. Okay, good, it works. You still do it, right? But in addition to this, you might use something like a Cucumber and there are other software. You actually you're coding this acceptance criteria, right? So you can execute them. Right? And then it helps with regression testing. It helps with a whole lot of things. Right? Really cheap, but hugely powerful. Production readiness. That's getting feedback from the system which replicates production system, right? It's much more valuable feedback than getting the feedback that it works on my PC or my Mac. Right? Monitoring, we talked about this. Concept to cache, that's just the main, hugely expensive, but that's the main thing, that's the real thing which tells us if it works or not, right? If our concept works or not. So the idea is, of course, the increments will be small, then it gets less expensive, right? Because if I have a really small increment, it's very easy and cheap to develop, cheap to test, cheap to deploy, right? And I just, oh, it worked, it's working. No, it's not working. Okay, it's easy to roll back, and it's not that expensive, right? And it moves a lot of time. It's similar to this, right? Whereas the way my increments are big, it's similar to these or these, right? It's much more expensive. It's a lot of rework. Can we shorten feedback loops? So we saw that Short feedback loop is great, long feedback loop is not so great, right? And if we can, then how? Anybody?
Reduce scope of what you're trying to develop.
Okay, so small product increment, right? Anybody else?
See, before you've built anything, you can get ideas in front of users. So paper prototypes or something that doesn't really work but gets feedback from the end user.
Yeah, yeah.
Start from the goal.
What's that?
Start from the goal.
Start from the goal.
And work backwards.
Okay. Okay. Yeah, as opposite to just let's do it, right?
Yeah.
You look, what is that you want to achieve?
I guess it allows you to just hit the core things that almost forces you to do space on it.
Just to increase the frequency, but that's kind of the same as reducing
Kind of same as.
reducing the increment.
Yeah. 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 So the suggestions that I have is starting with MVP. Identify what's really MVP for you, right? Don't tell me that this plus this is MVP. No, it's not. If you are building a website, right, for selling for bookstore, right, you are telling me that ability to send promotional emails is MVP. It's not. It's not. Deliver early and often, right? Early is this. Often is small increments, right? You're accepting Visa, MasterCard, and I don't know what's the American Express, right? Now you want to accept another some weird card that not many people have. Okay, good. It's small increment. Right? Don't try to build this whole thing with big thing for promotion emails, all kinds of promotional emails. No, just pick up one. It's small increment. Right? Show it to the market. Pair programming instead of traditional code reviews. Why is it better? Because when I do pair programming, I get immediate feedback all the time, and we know that code quality is very good. When I have code review, right? I have junior developer who's sitting and coding for a week. Now senior developer says, is that? Yeah, it's good. No, let me take a look at this. And senior developer looks at this and says, my God, it has to be really reading. It's not good. It's not good. What do I do? What do I do about this, right? So it doesn't really work. This code review doesn't work. It's too long, right? Too long to wait. Same as testing at the end of sprint. Too long, right? You need to move early. Many times, right? So give this feedback to junior developer, work with him. That's why pair programming. Yeah. I don't know if you know what testing pyramid is. Essentially, testing pyramid is on the top is UI testing, then system testing, then on the bottom is unit testing, right? Integration testing, unit testing, right? So push testing toward the bottom of the testing pyramid so that you do as much as possible in unit testing, as much as possible in integration testing, system testing, and as little as possible from the front end, right? Because it's much cheaper and much better to do it on the bottom, right? Faster feedback, cheaper feedback. Testing automation definitely makes the feedback short, because if I need to test something, if my test are not made, right, I'm writing something and I'm giving it to QA, I test it, right, at the end of the day, it tells me that it works, it doesn't, what the bugs are. If I have test automation, I just run the test. Continuous integration with different, we just talked about this, different type of groups, right? Immediate 2 hour, 6 hour, 12 hour group, depending on how slow the tests are. And the last thing is continuous delivery. We'll talk about this in a second. Can we make the feedback loops cheaper, right? We know that some feedback loops are really, really expensive, don't they? They're great, but they're expensive. And how we can do it. To make feedback loops cheaper, we have to invest in early testing and put test down towards the testing pyramid we just talked about. Invest in early feedback, right? So what does it mean invest in early feedback? So when product owner tells you, I'm sorry, I don't have time to look at this is wrong, this is bad, right? Invest in this, right? He needs to invest his time, the company needs to invest time, invest money into having the product owner whose full-time job is to work with customers and the development team, right? Giving early feedback, right? You need to get early feedback from customers, right? And my favorite slide. Right? I want cheap, fast, broad scope feedback, which really tells me that this thing is, I'm building the right product and I'm building it right, that it's going to work, right? How do I do it? That's what became really popular in recent years, continuous delivery. Right? So if I can build a system so that I can code within a couple of hours, push the button, and whatever I coded, the very small feature, very small product increment, can be delivered to production right away. Right? And verified right there that it's actually doing what you think it should do, right? That's what we want. Right? Very small increment, very cheap. It will tell us right away. So, if marketing department, say, right, and business has some idea, right, we come up with the simplest way possible of implementing this idea. We implement this idea, right, very quickly, maybe a day, maybe 2 days, really, really quickly. We have the whole pipeline to send it to production, right? So we're writing all the tests as we develop, right? Everything is is there. Also, we have all ATDD tests documented. And we push it to production. In production, we have a monitoring system which will tell us what we wanted, which will tell us whether the marketing department was right or wrong. Because marketing department told us that if in those days, in theory, our conversion rate should go up by 3%, right? If we have monitoring tools which will actually give us the feedback if conversion rate went up by 3% or stayed the same, right? Given everything else is the same, right? You know how to measure this, because this measurement is really, really important. That is great. So a couple of days, we have, instead of months. Right? The additional interesting thing is that when we build a lot of features, right? Build them together and reason them together, right? So marketing department had a lot of ideas, right? We put them all in one release, shipped out. It's really very difficult to measure the result of each one of them because it's combined, right? We don't know what drove it up, what drove the demand up, what drove the demand down, what improved our numbers, what was the effect? Because it's combined effect. We don't know now what to do, what to take out, what to enhance, right? So you really want one thing. Go in there, checking. Good. Okay, we need to tweak it. Let's tweak it. Even better. Okay. Or no, it's not working. Okay, roll that. So that's essentially continuous delivery. Just one word about, I know we are running out of time. Retrospective, it's a different type of feedback loop. It's not about the product. It's about how we work. It's about our process, right? So we are, let's say we are doing Kanban, right? Or we are doing Scrum, and we are coming to retrospective to ask the question, to get the feedback from team members. How is it working for you? Is it helping you? Does it make your day better? do you really want to come to work, right? Or when you come to work, you think, ah, again, right? Again, I have to do this. Again, I have to. It's going to be a pain because my CI server, it will take 5 hours now to do the build, and it will fail most likely because other people are checking in code that they didn't test before they check it in. It's a bit nightmare. I have to sit and half a day. I have to sit and fix bugs for people who went on vacation. Right? It's quite an unpleasant feeling when you have to work and do this, right? But it can be very different. It can be, yeah, I'm coming to work. I know this thing that marketing department just put up, and in a couple of days it should be done. It's really, really easy. Everything's working. Everything's on board. We all know what the goal is. We all know what we are doing, and we'll see if there's a result. It's completely different feeling, right? So in retrospective, it's the feedback, right? Again, but different type of feedback. It's not feedback from the product, but it's feedback from the process. How we set up the process. What essentially contributes to failure of utilizing feedback? Insufficient to frequent feedback, we talked about this. Too slow feedback, we now understand this. Interesting thing that too much feedback too often also would be not a very good thing, right? So if I have continuous integration server, which no matter what, builds the thing every 5 minutes, right? It's just another schedule, right? And sends emails to the whole department, no matter what, if it's successful or not, right? I don't do this feedback. I don't care. Nobody checked anything for in the last hour. And also, if it's green, I don't want to receive email. I want to receive email only if it fails, right? So, too much feedback is bad because you stop reacting to this feedback. You just redirect it right to the trash folder, right? Stop reacting to this feedback. Irrelevant feedback, the same thing, same example. Team is under pressure and ignores feedback, right? Classical example is we have to release at the end of the week, and I don't care how we do it. What? Stop writing tests. It will go faster. Stop writing tests, right? And people stop writing tests, right? So under pressure, right? No tests, no feedback. Great. And then it fails in production, of course, right? Because we didn't test it, right? They didn't even ignore feedback, they just didn't ask for feedback, right? Or they see that it starts failing, they say, okay, yeah, we'll figure that out later, let's just go. Right? Or no, we'll stop talking to the product owner, we'll just do it, we know it's how it should be. So this is not good. The recipe here is slow down. Instead of trying to speed up, slow down, okay? Get back to the normal rhythm. Product owner not asking, ignoring feedback from team and from customers is a classical thing. Right? Why? And the last thing, which a lot of companies and a lot of teams do not using feedback. This mostly is not technical feedback, but that's mostly business feedback, right? So if we measure something, if we know that this works, this doesn't, this is improving sales, this is not improving sales, right? This information will be rarely feedback into what development team will be doing in the next couple of weeks. Right? But it should. So essentially this is not using feedback. Or another example would be developers just keep working without showing what they're working on to the product owner, because ideally, right, if you're working on a story which takes 5 days to finish, it's quite a big story, but still 5 days to finish, right? You want to be showing these increments to the product owner every day, maybe a couple of times a day during these 5 days, right? So when you're done, product owner already knows what's there, right? It's not a surprise for him. God forbid to wait till the demo, right? So you want this. Yeah, you want to show it all. You move the button, you change the color, right? You move the description. This is how you want it. Yeah, can you tweak this? Yes, okay. And in a couple of hours, this is how you want it. Yes. So the idea is to deviate, right, from the ideal course, at least as possible. I have nothing to add here, right? And that's about it. Any questions? So sorry, I've overrun 6 minutes. Any questions?
Within the feedback loop itself, where would you say estimates or something like size, cut to complete, time to complete fit?
I'm sorry,
Within your feedback loop, one thing I didn't see was things like an estimate or a view of time to complete. I see it's 10 story points, in reality it's 20 or it's 25. I know that from day one, but if I don't feed that back into the loop, I'm going to get disappointed ultimately.
So how you feed back into the loop estimate, right?
Yeah, so it could be if you're doing the initial development and you think it's about 3 days work.
Right.
If you looked at it, it's actually probably 3 days, it might have been 20 because something wasn't there that I thought was there. After day one, I realised it's going to be 20 days development, not 20.
Okay.
Yeah, so that your time to complete goes out the window, your testing efforts are going to change, and so on. Knowing that early means you're not going to realise your return on investment or value. You might say, you better stop now. Or you need to revisit all the other things that fit within your development.
So the situation that you're describing usually happens in very immature teams, right? When the team is mature, right? When the product owner knows what he's doing, when the team knows what he's doing, this would almost never happen, right? So what you're describing is you have a story, simply good, didn't do it. We start doing it, and we estimated that it will take us, I don't know, whatever story points, and we think that's a 3-day story. After half a day, we know that no, it's 20-day story at least, and, right?
Yeah.
It means that we didn't talk enough about the story. It means that there was not enough product backlog grooming. It means that product owner and the team did not communicate enough about this story, right? Or another option is that it's very, we are doing something that we've never done, right? We don't know this technology, we don't know if it's feasible, right? We said we will do it, but as we started, we actually see it. So the answer to this is spike story. So you just do the spike story. So instead of committing to doing thing and having the story production ready, right? You say, I'm doing the spike story, meaning the only I will not put anything, I will not build anything. The only result from the spike story will be answer to the question. Can I do it? And how am I going to do it? Without going into details, right? And how long it's going to take. That's what you want to get out of spike story, right? And then, once you know the answer to the question, then you can better plan your story. Okay. Any more questions? No? Okay. Thank you very much, and I hope it was not too technical, and I was trying to adjust so that there will be balance between business side and technical side, but the thing is that feedback works kind of on both sides of it. Okay, please go. Yeah.